on the idea of calculating the volume of a solid using a slicing method. Consider a loaf of bread. How do you calculate the volume? Well, you can slice this up into small pieces and calculate the volume of a small piece and then add them all together. Or you could basically slice it up into very, very tiny little pieces and then find a little area and then add those areas together to put together to find the volume. The same for the watermelon. How do you calculate the volume? Well, in this case, you can just slice this up and calculate each small volume, add them all together to find the total volume. Or if you assume these slices are very, very tiny, you can basically calculate the area and then find the Riemann sum of the area times delta x, and then take the limit to define the definite integral. So in general, we have general slicing method. Suppose a solid object extends from A to B on x-axis, and the cross-section of the solid perpendicular to the x-axis has an area given by a function A that is integrable on closed interval A to B. Then the volume of the solid is the definite integral of this area A of x dx. X ranges between A to B. Going back to the loaf of bread, and in calculus, in general, if you have an object in the space and then you find a cross section with this plane, and here you have the area function A of x. When you're taking the integral, the definite integral of A of x, x ranges between A to B, it means that you have this area or this slice lined up next to each other and add them all together, and it defines your volume. Let's take a look at one example together. A pyramid with 3 meters height has a square base that is 3 meters on the side. The cross-section of the pyramid is perpendicular to the altitude x meter down from the vertex and is a square x meter on a side. Find the volume of this pyramid. Okay, the cross-section at x is square x meters on a side. So its area is x squared. Take a look at this visualization. Here you have a pyramid. Based off of the information from the example, you know that it has 3 meters in height. So from 0 to 3, you have the height of this pyramid. It also has a square base that is 3 meters on a side. So you have the square base, which is basically this base down here. Now, the cross-section of the pyramid perpendicular to the altitude x meter down from the vertex is a square x meter on a side. Okay, perfect. So as you can see, a typical cross-section is square. So this area is nothing but x squared. But how do we calculate the volume of this pyramid? To calculate the area of this pyramid, we basically multiplied x by x. Now to find the volume is the definite integral of A of x, x ranges between 0 to 3 dx. This can be written as x squared, which is your A of x, the definite integral 0 to 3 with respect to x. Remember the formula, how do we take the integral of u to the n du? This is u to n plus 1 divided by n plus 1 plus constant of integration. So applying the formula, you get x cubed divided by 3. X ranges between 0 to 3. When you plug in 3, you get 27 divided by 3, or 9 cubic meter. This is the volume of this object using general slicing method. So again, basically, you just need to find the area of the cross section and then take the integral. X ranges between 0 and the maximum value it takes is 3. And this slice is repeating itself with smaller squares and then larger squares. But instead of calculating each little piece one by one, we take the definite integral of the area.